Hello all, welcome to Unacademy. Today we will going to see our first topic or first lecture on complex analysis. Okay, we will see in this lecture we will see how to find out the analytic function or check whether it is given function is analytic or not, and we will find out the CR equations. Okay, so that we will see in detail in this lecture, so keep watching. Before going to start this, I will introduce myself Dhanashree Mam. I completed my MSc in mathematics from Mumbai University, and I am also having a teaching experience of 13 years, and I mentored more than 10,000 plus students for the engineering. Now, after that I will tell you how to install the Unacademy's learning app. पहले आपको अपने मोबाइल पे प्ले स्टोर ऐप पे अनअकैडमी का लर्निंग ऐप सर्च करना है, उसके बाद इंस्टॉल करना है. देन you have to manage your goal, that is which goal you want to study. जैसे कि हम लोग अभी गेट एंड ईएसई के लिए प्रिपेयर कर रहे हैं, तो गेट एंड ईएसई यहाँ पे हमने मैनेज किया हुआ है goal. And then you can choose any subscription plan, that is either plus subscription, free courses, special classes. You can see every plan का different use है. जैसे कि आप लोग यहाँ पे स्पेशल क्लासेस ले रहे हैं तो आपको 1-to-1 यहाँ पे गाइडेंस मिलेगा, और प्लस क्लासेस के भी अलग बेनिफिट्स है आपको मिल जाएंगे यहाँ पे. So you can choose any one of this, and after that press the get subscription button, and after that you have to manage your goal for which month, for how much month you want to prepare it. So that is, suppose यहाँ पे आप लोग 24 months के लिए prepare करना चाहते हो, 12 months के लिए prepare करना चाहते हो, so accordingly you are need you can choose your subscription plan. And if you want 10% discount on your subscription fees, then you can use my promo code, that is TSP, to get the 10% off on your subscription fees. And after that you can pay by using any one of this method your subscription fees. Okay, thank you. Now we will go over we will go to see our actual topic, that is function of complex variable. Okay, so what do you mean by functions of complex variable here? See, first of all we will see how to find out the whether the given function is. See, हमने पहले भी यहाँ पे पढ़ा है कि complex numbers Argand diagram, everything we have seen. The complex number can be written in the form of, here f of z is equal to, you can write here u plus iv, where u is a real part, v is a imaginary part. Okay, everything we will see here, how to find out the complex number, or how to write express the complex number. Now let z is equal to, let z is equal to r e raised to I theta. So where z is equal to x plus iy be any complex number where x and y belongs to r, and I is equal to root of -1. Root of -1 is denoted by the letter r, generally it is by letter r. I is equal to root of -1. And here z is equal to, in polar form you can write this complex number as z is equal to r into cos theta plus I sin theta. But cos theta plus I sin theta is nothing but e raised to I theta. Okay, where here r is equal to root of x square plus y square is called as modulus or magnitude of a complex number. Okay, is called as modulus or magnitude of a complex number, where theta is equal to, here z is equal to, mod of z is equal to r plus under root of x square plus y square, where theta is equal to tan inverse of y by x is called as argument or amplitude of a complex number z. This is a prerequisite we require to find out the analytic function, or by using CR equations, or we will use how to find out the, if one u is given, then how to find out v by using CR equation. So for that these things are required. Now number z is equal to x plus iy, where amplitude of z is equal to argument of z, which is equal to theta, which is equal to tan inverse of y by x. Since z is equal to r e raised to I theta. Okay, z is equal to r e raised to I theta, so you will get here general value of the logarithm of a z is log z is equal to log r plus I into 2n pi plus theta, where 1 by 2 is equal 1 by 2 into log of x square plus y square. ठीक, मैं अपना काम कर रही हूँ, आप यहाँ पे पढ़ लो, क्या मजा आ रहा है अकेले पढ़ने में. ओके, while log of z is equal to log of r plus I into 2n pi plus theta is equal to 1 by 2 into log of x square plus y square plus I into 2n pi plus tan inverse of y by x. By putting n is equal to 0, we get the principal value of logarithm of z is log z is equal to log r plus I theta, where 1 by 2 into log of x square plus y square plus I into tan inverse of y by x. Okay, यहाँ पे हम लोग देखेंगे पहले definition of a complex number. If x and y are real variables, then z is equal to x plus iy is called a complex variable. Okay, जयेश, आपको समझ में आ रहा है जो भी पढ़ा रही हूँ? If x and y are real numbers, then z is equal to x plus iy is called a complex variable. If for each value of the complex variable z is equal to x plus iy in a given region R, then there exist one or more values of another complex variable w is equal to u plus iv. See, generally हम लोग क्या लिखेंगे यहाँ पे? Then w is called a function of the complex variable z. Here we can write w is equal to f of z, where f of z is equal to u plus iv in general. Here w is equal to f of z is equal to u plus iv, and which is equal to x plus iy. U is a function of u and v, both are functions of x and y. So here you can get here u plus u of xy plus iv of xy. Okay, u of xy plus iv of xy. No. Now, analytic function. A single valued function f of z possesses a unique derivative with respect to z to all points to a region R, is said to be analytic function or regular function or a holomorphic function of z in R or monogenic function. Okay, a single valued function. When we say that the given function f of z is analytic, the function f of z is analytic if it possesses a unique derivative with respect to z to all points to a region R. Okay, now the singular point, a point where a function ceases to be analytic is called as singular point, or the point at which the function ceases to have a derivative. मतलब जिस point को हमें derivative नहीं मिल रहा है, that point is said to be singular point. Okay. Now see, the main point in this lecture is Cauchy-Riemann equations. So what are that equations? The necessary and sufficient conditions for the function w is equal to f of z, which is equal to u of xy plus iv of xy to be analytic function in a region R, are dabba u by dabba x, dabba u by dabba y, dabba v by dabba x, and dabba v by dabba y are continuous functions of x and y in the region R. Okay, all are continuous functions of x and y in the region R. So dabba u by dabba x, these conditions are very important. It is Cauchy-Riemann equations. Okay, dabba u by dabba x is equal to dabba v by dabba y, and dabba u by dabba y is equal to minus dabba v by dabba x. The condition 2 is known as Cauchy-Riemann equations or CR equations. These conditions are very important to find out the given function is whether analytic or not. Okay, so in that case we will check whether the given function f of z satisfies this CR equation. Then we say that the given function is analytic. Okay. Now, Cauchy-Riemann equation, this is in a Cartesian form and this is in a polar form. Okay, let r theta be a polar coordinates of a point whose Cartesian coordinates are xy. Then x is equal to r cos theta and y is equal to r sin theta, where z is equal to x plus iy, which is equal to r e raised to I theta. Then f of z is equal to f of r e raised to I theta, which is equal to u plus iv. Now differentiating equation partially with respect to r, we get dabba u by dabba r plus I dabba v by dabba r is equal to f dash of r e raised to I theta into e raised to I theta. So after equation you will get Dabba u by dabba theta plus I dabba v by dabba theta, which is equal to f dash of r into r e raised to I theta into I r e raised to I theta, which is equal to I r into dabba u by dabba r plus dabba v by dabba r, which is equal to minus r dabba v by dabba r plus I r dabba u by dabba r. Now equating the real and imaginary parts, we get dabba u by dabba theta. Now here you can see here dabba u by dabba theta plus I into, here you will get dabba u by dabba theta plus I into dabba v by dabba theta, where dabba u by dabba theta is equal to minus r dabba v by dabba r, and dabba v by dabba theta is equal to r dabba u by dabba r. Now dabba u by dabba r is equal to 1 upon r into dabba v by dabba theta, and dabba v by dabba r is equal to minus 1 upon r into dabba u by dabba theta. Okay. Now, what do you mean by harmonic functions? The function which satisfies the Laplace equation is known as harmonic functions. Okay, the function which satisfies the Laplace equation is known as harmonic function, or any solution phi of the Laplace equation dabba square phi upon dabba x square plus dabba square phi upon dabba y square is equal to 0 is called as harmonic function. Now, Millen-Thomson method. What do you mean by Millen-Thomson method? So, whatever your f of z is given, f of z is equal to u of xy plus iv of xy, and z is equal to x plus iy, replacing x by z and y by 0. Now, we have to remember, whenever it is replacing it this, you can write here f of z is equal to replace x by z. So, you will get u of z0 plus I into v of z0. Right? So your f of z becomes like this. F of z is equal to u of z0 orthogonal system. Two curves are said to be orthogonal to each other when they intersect at right angle to each other at their point of intersection. Okay. Now, first one, if w is equal to log z, okay, if w is equal to log z, then if w is equal to log z, then we will find dw by dz and determine where w is non-analytic. It means at which point the given function w is equal to log z is non-analytic. So for that, what we will do, we will find out whether the given functions are satisfied the CR equation or not. So what are the CR equations? So dabba u by dabba x is equal to dabba v by dabba y, and dabba u by dabba y is equal to minus dabba v by dabba x. Okay, so we will check whether this is called this as equation number 1. So whether we will check whether the given w is equal to log z satisfies this equation 1 or not. Okay, so we'll get w is equal to log z, which is equal to log z, it means what, u plus iv, w is equal to u plus iv, which is equal to log of x plus iy. So we will get which is equal to log r plus I theta, which is equal to w is equal to, you will get log of, here u is equal to, here you will get log of r, but log of r it means log of x square plus y square bracket raised to 1 by 2 plus I into theta, it means tan inverse of y by x. Okay, so here tan inverse of y by x, this is our u, and you can write v is here, w is equal to log of this. So ultimately your u is equal to here log of x square plus y square bracket raised to 1 by 2, and v is equal to tan inverse of y by x. Okay, v is equal to tan inverse of y by x. Okay, so dabba u by dabba x, first we will calculate dabba u by dabba x is equal to, see, log of, first we will write here u is equal to log of x square plus y square bracket raised to 1 by 2. Here log of x square plus y square bracket raised to 1 by 2 and v is equal to tan inverse of y by x. V is equal to tan inverse of y by x. So we will get here w by x is equal to w by x is equal to here, so 1 by 2 into log of u. So 1 by 2 into log of x square plus y square 1 upon u x square plus y square bracket raised to 1 by 2 into n into first 1 upon u. So you will get into x square plus y square bracket raised to 1 by 2. Okay. Here x square plus y square bracket raised to 1 by 2 1 upon x square plus y square bracket raised to 1 by 2 into x square plus y square bracket raised to 1 by 2 minus 1, it means minus 1 by 2. Okay, this is your w by x into derivative of x square plus y square with respect to x is 2x. Okay, so 2 cancel out. So here you will get w by x is equal to x raised to minus 1 by 2 and here x raised to minus 1 by 2. So you will get x raised to minus 2 by 2, it means x raised to minus 1, it means x square plus y square into x. So x upon, you will get x square plus y square. Okay. Now w by y. W by y, differentiating this with respect to y. So you will get w by y is equal to 1 by 2 into 1 upon x square plus y square bracket raised to 1 by 2 into x square plus y square bracket raised to minus 1 by 2. Okay. Now you will get here 2y. 2 to get cancelled out. So you will get ultimately w by y is equal to y upon x square plus y square. This is your w by x and this is your w by y. Okay. Now we will calculate v by x. So here v is equal to tan inverse of y by x. So we will calculate v is equal to our v by y is equal to 1 upon 1 plus y square by x square into 1 upon x, right, which is equal to x upon here x square plus y square, because this x square plus y square upon x square in the numerator, so x cancel out, x upon x square plus y square. Therefore w by x is equal to x upon x square plus y square. Okay, and v by is equal to v by y. The first equation satisfied. Now we will calculate v by x. So v by x, we will get v by x is equal to 1 upon 1 plus y square upon x square, that is minus y upon, no, there is 1 upon x, minus y upon x square equal to x square plus y square, x square cancel out, minus y upon x square plus y square. Okay, so you will get w by x is equal to x upon x square plus y square. So this is nothing but minus dabba u by dabba x, right? So minus dabba u by dabba x is equal to this. So if you observe here, satisfy dabba u by dabba x is equal to dabba v by dabba y. Dabba u by dabba x is equal to dabba v by dabba y. Dabba v by dabba y. Here x upon x square plus y square, and dabba u by dabba y is equal to minus dabba y is equal to minus dabba v by dabba x, minus dabba v by dabba x. So ultimately you will get dabba v by dabba x is equal to minus dabba u by dabba y. Now see, determine which of the following functions are analytic. Okay, determine which of the following functions are analytic. So which of the following function is analytic? Determine which of the following functions are analytic. Now see, 1 upon 1 plus 1 minus z. So here your f of z is equal to u plus iv is equal to 1 upon 1 minus z, right? So which is equal to 1 upon 1 plus minus x plus iy is equal to 1 upon 1 minus x minus iy, right? So we will get f of z is equal to here 1 upon minus x minus iy into, rationalizing it, we will get 1 plus 1 minus x plus iy upon 1 minus x plus iy, right? So is it nothing but 1 minus x plus iy upon, यहाँ पे होगा a plus b into a minus b. So a plus b, a minus b, so this will becomes a square minus b square. So you will get a square here, 1 minus x bracket square plus y square. Okay, so you will get here plus y square. So f of z is equal to here, so u is equal to, your real part is 1 minus x upon 1 minus x square plus y square minus x bracket square plus y square, and v is equal to y upon 1 minus x bracket square plus y square. So u is equal to this, v is equal to this. So you will get ultimately, check whether the given function is analytic or not. So calculating dabba u by dabba x, dabba u by dabba y. Okay. So here u is equal to your 1 minus x upon 1 minus x bracket square plus y square, right? So you will get ux or dabba u by dabba x is equal to, now v du, v is 1 minus x bracket square plus y square into derivative of this 1 minus x with respect to x is minus 1 minus u into dv, 1 minus x into derivative of this. So you will get 2 into 1 minus x into minus 1 plus 0. Okay. So ultimately you will get here upon 1 minus x bracket square plus y square bracket raised to 2. So dabba u by dabba x is equal to, you will get if you see 1 minus x, so 1 minus x bracket square plus y square into minus 1. So you will get here minus of so ultimately this will becomes minus 1 minus x square, or this is also minus y square. 1 minus x into 1 minus x. So if you multiplied with this, so 2 into 1 minus x bracket square and this minus 1, so becomes plus. Okay, upon 1 minus x square which is equal to 2 into 1 minus x bracket square minus 1 minus x bracket square is equal to 1 minus x bracket square minus y square upon you get 1 minus x bracket square plus y square bracket square 1 minus x bracket square plus y square bracket square. Okay, so this is your dabba u by dabba x. Next we will get now all this is dabba u by dabba y. So exactly similar way you will get dabba u by dabba y v du into derivative of this, that is 2y minus u dv. U is 1 minus x v into okay तो 0 ही बन जाएगा right. U into derivative of v, u into derivative of v du v into derivative of u, that is with respect to y, so it is u, right, minus u into dv derivative of v, तो इसका तो डेरिवेटिव 0 ही बन जाएगा तो 2y हो जाएगा right और 1 minus x square plus y square brackets ये 0 बन गया, ये हो गया minus 1 minus x into 2y upon 1 minus x bracket square plus y square bracket raised to 2. ठीक, ये बन गया dabba u by dabba y और ये dabba u by dabba x. Now we will calculate dabba v by dabba x and dabba v by dabba y. V is y upon 1 minus x bracket square plus y square. So v is equal to y upon 1 minus x bracket square plus y square. Now dabba v by dabba x. We will get here v du. V is 1 minus x bracket square plus y square, but into derivative of y with respect to x ये तो 0 बन गया minus u dv for derivative of v with respect to x. So 2 1 minus x and इसका derivative तो 0 बन गया right upon 1 minus x bracket square plus y square bracket raised to 2. Okay. So dabba v by dabba x is equal to here 0 minus y into 2 into 1 minus x upon 1 minus x bracket square plus y square bracket square right. तो ये क्या हो गया 2 into 1 minus 2y minus minus plus xy 2xy minus 2x into y minus 2 plus 2x. So here you will get 1 minus x bracket square plus y square bracket raised to 2. So dabba v by dabba x is equal to this. Dabba v by dabba x is equal to this. Now we can check here whether the given functions are satisfying the CR equations or not. So here dabba u by dabba x is equal to 1 minus x square minus y square. So dabba u by dabba x is equal to dabba v by dabba y. This is your dabba v by dabba x only. Now we will calculate dabba v by dabba y. So v du 1 minus x bracket square plus y square into derivative of y with respect to y minus v du into y into bracket derivative of this, that is 2y. ये बन गया 1 minus x bracket square plus y square, right? So 1 minus x square plus y square, is it nothing but above v by above y, 1 minus x bracket square minus y square minus 2y square plus y square minus y square, 1 minus x bracket square minus y square upon 1 minus x bracket square plus y square. Okay, this is your 1 minus x bracket square minus y square upon 1 minus x bracket square plus y square. So dabba v by dabba y. Okay. So this will be your dabba v by dabba y. Now we will see. So if you observe dabba u by dabba x is equal to dabba v by dabba y by u by dabba x is 1, equation number 2, equation number 3 is equation number 4. If you observe equation 1 and 4, equation 1 and equation 4 are same. It means dabba u by dabba x is equal to dabba v by dabba y, and dabba u by dabba y is equal to, now see, if you see equation number 2 and equation number 3, okay, so you will get 2 into bracket xy minus y, here minus 1 into bracket 2x2y into 2xy. So obviously equation 2 and equation 3 are same. So you will get dabba u by dabba y is equal to minus dabba v by dabba x. So therefore it satisfies the CR equations. The CR equations are satisfied. Hence partial derivatives are continuous everywhere except at x is equal to 1. See here. Except at x is equal to 1 and y is equal to 0. Okay. So we can write here. The CR equations are satisfied. Thus, CR equations are satisfied and partial derivatives are continuous, and partial derivatives are continuous then everywhere is continuous everywhere except at x is equal to 1 and y is equal to 0. Okay, that is we can write z is equal to x plus iy, so which implies z is equal to 1 because x1 y0. Okay, so partial derivatives are, they are continuous everywhere at z is equal to 1. Therefore here f of z is analytic everywhere except at, therefore f of z is analytic one upon 1 minus z, right? Here f of z is equal to 1 upon 1 minus z. So 1 upon 1 minus z, so you will get f dash of z. So it is your f dash of z minus 1 upon 1 minus z bracket square. So which into minus 1, right? So which implies and z is not equal to 1. Here z is not equal to 1. Okay. Third one. Second one is given f of z is equal to sin z. Okay. Is equal to sine of x plus iy. Second कर दे अभी. Second here here f of z is equal to here f of z is equal to 1 sin z. Of z is equal to sin z, so which is equal to sine of x plus iy. But sin x plus iy, it means sin a plus b, sin a cos b plus cos a b, right? So here your u is equal to cos x cos hy, okay, plus and uv is equal to cos x sin hy. Okay. Here cos iy is equal to cos hy. Okay. And here sin iy is equal to sin hy. So u is equal to this, v is equal to this. We can calculate dabba v by dabba x. Dabba u by dabba x. So dabba u by dabba x is equal to here we'll get cos x into cos hy. Here your u is equal to sin x into cos hy. Okay. And v is equal to cos x into sin hy. So dabba u by dabba x क्या हो जाएगा? Cos x into cos hy. And dabba v by we'll get dabba v by dabba y. Cos x into cos hy. Okay. Dabba u by dabba y is equal to sin x into sin h. And dabba v by dabba x minus sin x into sin hy. So if you observe dabba u by dabba x is equal to minus dabba v by dabba x. Now dabba u by dabba x is equal to dabba v by dabba y, and dabba u by dabba y is equal to minus dabba v by dabba x. Therefore CR equations are satisfied. CR equations are satisfied. Okay. CR equations are satisfied. So therefore we can write here f of z is analytic everywhere except at f dash of z is equal to cos z. Therefore f of z is analytic everywhere except at f dash of z is equal to cos z. Okay, this is very important. So given function f of z is analytic everywhere f dash of z is equal to cos z. Okay. See our next example. If v is equal to 3x square y minus y cube, find the analytic function f of z in terms of z. This is very different example. Here we will see f dash of z. If v is equal to 3x square y minus y cube, find the analytic function f of z in terms of z. So whenever we are finding in terms of z, we will use the Millen-Thomson method. Okay, so for that, first we will write down here f of v is equal to given 3x square y minus y cube. So as it is analytic, so it must satisfy the CR equation. Okay, so here we can write dabba v by dabba x is equal to, so it is our dabba v by dabba x 6xy, right? Now dabba v by dabba y is equal to 3x square minus 3y square, right? 3x square minus 3y square. Now we know that as f dash of z, f of z is equal to what? What? U plus iv, right? So what is our f dash of z? Dabba u by dabba x plus I dabba v by dabba x, or which is equal to, now we can consider here dabba u by dabba x as it is satisfied the CR equation. So dabba u by dabba x is equal to, we know that dabba v by dabba y plus I into dabba v by dabba x. Okay, so your f dash of z becomes dabba v by dabba y is 3x square minus 3y square plus I into dabba v by dabba x is 6xy. Right, so this is your equations. Now this is your f dash of z. We require a function f of z in terms of z, so f dash of z is here. So we can calculate f of z by Millen-Thomson method. By Millen-Thomson method we replace x by z, x by z and y by 0, x by z and y by 0. So we will get f dash of z is equal to here f dash of z is equal to 3z square minus 3y, that is 0. So 3z square plus here I into y is equal to 0, so it is 0. So f dash of z is equal to 3z square. Now integrating on both sides. Integrating on both sides. Integrating on both sides will get integral of f of z, f dash of z is z. Integration derivative get cancel out. So you will get here after integrating 3 into z cube by 3 plus constant of integration. So your f of z is equal to z cube plus c. This is your function f of z. Okay, so f of z is equal to z cube plus c, or other alternative method also there, u plus iv. You can calculate above v by x and then calculate u, and you can write f of z is equal to u plus iv. So वो भी method आप लोग कर सकते हैं, but this is I think simplest method to find out the analytic function f of z in terms of z. Find the analytic function f of z if u is equal to given. So u is equal to e raised to minus x into x sin y minus y cos y. Okay, so u into e raised to x minus x into x sin y minus y cos y. So we will find out here u is given. Okay, so we will calculate dabba u by dabba x. So u into v rule, first into derivative of second sin y minus derivative of this 2 plus second into derivative of first, that is minus e raised to minus x into x sin y minus y cos y, right? E raised to minus x into sin y minus e raised to minus x into x sin y minus y cos y, right? So this is your function dabba u by dabba x. Now dabba u by dabba y. So dabba u by dabba y is e raised to minus x into bracket sin y minus x sin y minus minus plus y cos y, right? So you will get dabba u by dabba y is equal to here e raised to minus x into bracket x cos y, e raised to minus x into bracket x cos y minus cos y plus y sin y, right? So this is your dabba u by dabba y and dabba u by dabba x. Okay. So that is dabba u by dabba x and dabba u by dabba y. So dabba u by dabba x is this. Dabba u by dabba y is minus x into x cos y minus cos y plus y sin y. Correct. Now we can write f dash of z. So what is your f dash of z? Dabba u by dabba x plus I dabba v by dabba x, which is equal to, we can write dabba u by dabba x, dabba v by dabba x, it means minus I dabba u by dabba y, right? So we can write f dash of z is equal to Here e raised to minus x into bracket sine y. Dabei u by dabei x is e raised to minus x into bracket sine y minus x sine y plus y cos y minus I into e raised to minus x into x cos y minus cos y plus y sin y. Right? So by Millen-Thomson method, so I e raised to minus x, x cos y minus cos y plus y sin y. This is your f dash of z. Now by Millen-Thomson method, replace x by z and y by 0. Right? Replace x by z and y by 0. So we get f dash of z is equal to e raised to minus z into bracket y0 sin 0 0 sin 0 0 y0. So this will become 0 minus, so 0 minus 0 plus 0 minus I e raised to minus z into bracket cos 0 1 and z. Here cos 0 1 minus 1 and here is 0. So minus I e raised to minus z, z minus 1. Okay. Now this will become, so integrating on both sides, so we will get f of z is equal to, now e raised, here f dash of z is equal to e raised to minus z minus I e raised to minus z into z minus 1. Okay, so we will take here, this is same as minus I into, now if I take e raised to minus z common into bracket 1 minus I into z minus 1. Right, तो ये हो जाएगा I z z minus 1 into I dz raised to minus z I e raised to minus z. So this will give you f dash of z. So integrating on both sides, so you will get f of z is equal to minus of I into integral of e raised to minus z into z minus 1 z plus c. So that is minus I into bracket, written the first using by parts here, written the first into integral of second e raised to minus z upon minus 1 minus integration of derivative of first. So derivative of first, it means z minus 1 का derivative हो जाएगा 1 into integral of second e raised to minus z upon minus 1 dz. So minus I into bracket z minus 1 into e raised to minus z. So minus, ये minus और ये minus becomes plus. So integration of e raised to minus z upon minus 1 plus c. So you will get here I into bracket minus I e raised to minus z into bracket minus z plus 1 minus 1 plus c, right? Minus I e raised to minus z plus 1 minus 1 cancel out into minus z plus c. The minus minus becomes plus. So I z e raised to minus z plus c. This is your f of z. Okay. So f of z is equal to this. Now, the second one is fifth one. Find a such that the function f of z is equal to r square cos 2 theta plus I r square sin a theta is a analytic function. यहाँ पे अभी analytic function है, इसे बोला है, so it means it must satisfy the CR equations. Then we have to find out the value of a here. Okay, so we'll see how to find out the value of a here. Now see, here u is equal to, now it is a function of r. So you will get f of r is equal, f of z is equal to here r square cos 2 theta plus I r square sin a theta is an analytic function, is an analytic function, is an analytic function. Then we can write f of z is equal to, here u is equal to over r square cos 2 theta and v is equal to r square sin a theta, right? U is equal to r square cos 2 theta and v is equal to r square sin a theta. So you will get here dabba u by dabba r. So here is 2r into cos 2 theta, then dabba v by dabba r. So 2r sin a theta, right? Here dabba u by dabba theta. So you will get dabba u by dabba theta as r square into cos 2 theta, it means minus 2 sin 2 theta. Minus 2 r square into sin 2 theta. Now dabba v by dabba theta is equal to 2r into cos a theta, right? 2ar cos a theta. Okay. So now if you observe by CR equation, since f of z is analytic, it is given f of z is analytic. Okay, as f of z is analytic function, right? As f of z is analytic function, what we will get? So here f of by CR equations, we get dabba u by dabba theta. So here dabba v by dabba theta, we write dabba v by dabba theta is equal to r dabba u by dabba r, and dabba v by dabba r is equal to minus, we can write here dabba u by dabba theta is equal to minus r dabba v by dabba r, right? So here therefore we can write dabba v by dabba theta is a r square cos a theta is equal to dabba u by dabba r is equal to 2r square cos 2 theta. Okay. And here dabba u by dabba theta is equal to minus 2r square sin 2 theta, minus 2r square sin 2 theta, and dabba v by dabba r is equal to minus r into dabba v by dabba r. So dabba v by dabba r is 2r sin a theta and this minus, so minus 2r square sin a theta, right? Now if you see here, here you will get minus 2r square sin a theta. Now comparing these two, you will get r square sin 2 theta. So a is equal to here 2, right? So which implies a is equal to 2. By comparing the LHS and RHS, we'll get a is equal to 2. Okay, so we'll get here f of z is analytic function. If then it must satisfy the CR equations. Then by using that this condition, we can find out the value of a. Okay. Now we'll say the next one, that is sixth one here. If u is equal to x cube minus 3y x cube minus 3y square x, there must be a y square, huh? X cube minus 3y square x, find its harmonic conjugate v and find f of z in terms of u plus iv in terms of z. तो यहाँ पे u दिया हुआ है और v निकालना है, right? So if u is given, then how to find out v? So first u is equal to, so as it harmonic conjugate we have to find out, it means u given, we have to find out v. U and v are harmonic conjugate. So as u is equal to this, so dabba u by dabba x first calculate, that is 3x square minus 3y square, right? 3x square minus 3y square. Now deba u by deba y. So you will get here minus 6xy, minus 6xy, right? Now once you get this, since v is harmonic conjugate of v, since v is harmonic conjugate of u, harmonic conjugate of v is a harmonic conjugate of u. So therefore it must satisfy the CR equation. So what we will do is a v is equal to, v is a function of xy. So we will find out dv is equal to deba v by deba x into dx plus deba v by deba y into dy. Okay. As it satisfies the CR equation, so deba v by deba x is equal to minus deba u by deba y into dx plus deba u by deba x into dy, replacing these two by CR equations. Deba u by deba x is equal to minus deba v by deba minus deba u by deba y. Okay, and deba v by deba y is equal to deba u by deba x. Now we have all the values here. So dv is equal to, you can write here deba v by deba x is 6xy dx. Now you can see here minus 6xy, so plus deba u by deba x is 3x square minus 3y square dy plus 3x square minus 3y square dy. Okay. 3x square minus 3y square dy. This is dv. dv is equal to this. So you will get f of z is equal to, so is this nothing but dv is equal to, is an exact function. So you will get v is equal to, it is nothing but the mdx plus ndy form. So we can calculate v as integrating on both sides. So integration of dv, so you will get v is equal to integration of xy 1 dx keeping y constant plus terms of f2 which are free from x. Okay, so only one term है यहाँ पे minus 3y square dy plus c. The integration with respect to x हो जाएगा 6x square by 2y. Okay, minus 3 into y cube by 3 plus c. तो ये हो जाएगा 3x square y minus y cube plus c. Okay, 3x square y minus y cube plus c. This is your v. So your function f of z is, we can write here function f of z is u plus iv. Okay. So here u is equal to, already given, u is x cube minus 3x square 3y square x cube minus 3y square x plus I into 3x square y minus y cube plus c. Okay, f of z is equal to this. This is your f of z. Okay. Now it's a harmonic conjugate, and after finding out it, we can write f of z in terms of, so in terms of z by Millen-Thomson method, we can replace the Millen-Thomson method. We replace x by z and y by 0. Okay. So here f of z is equal to x by z, it means z cube minus y 0. So this is again 0. So plus I into y 0, this y 0. So plus y is equal to z cube ic. This is your f of z. f of z is equal to z cube plus ic. This is your function f of z. when harmonic conjugate is finding out. After that we'll see if u is equal to 1 by 2 log of x square plus y square, find its harmonic conjugate v such that f of z is equal to u plus iv is an analytic function and hence determine f of z in terms of z. Is very important. Now see here u is given exactly similar way we have to find out the v here. Okay, so how we find out the v? So you will get here u is equal to this. So calculate del by u by del by x first. 1 upon u into derivative of this, that is 2x square. Is 2x. So 2 cancel out, so you will get x upon x square plus y square. Right? Del by u by del by y by 2 into 2y upon x square plus y square. Okay. Nothing but y upon x square plus y square. This is del by u by del by x and this is del by u by del by y. Since f of z is analytic function. Since f of z is analytic function. Then by CR equations, we get del by u by del by x. Del by u by del by x is equal to del by v by del by y. And del by u by del by y is equal to minus del by v by del by x. So here del by u by del by x is equal to this. And here v is a function of xy. So we can write dv is equal to del by v by del by x into dx plus del by v by del by y into dy. Right? We can replace del by v by del by x as minus del by u by del by y into dx. Right? Plus we will get here del by u by del by x into dy. So dv is equal to minus y upon x square plus y square into dx plus x upon x square plus y square into dy. Okay. You will get du is equal to, it's like du m dx plus m dy. So integrating on both sides, we will get v is equal to integration of f1 dx. So f1 is minus y upon x square plus y square dx, right? So we'll get minus y upon x square plus y square dx, so which is equal to x square plus y square dx plus terms of keeping y constant plus terms of f2 which are free from x and y. So 0 term here is free from x and y plus c. So here v is equal to, this is tan inverse of, that is minus into tan inverse of y by x plus c. So you will get v is equal to minus tan inverse of y by x. Now, so for analytic function f of z is equal to, for analytic function f of z is equal to u plus iv. So f of z is equal to, here u is by 2 log of square plus y square plus I into, अभी यहाँ पे होगा minus I into tan inverse of y by x. Okay, by Millen-Thomson method we can write, here is put, replace x by z and y by 0 by Millen-Thomson method. We will get f of z is equal to 1 by 2 log of z square minus I into tan inverse of y0 tan inverse 0 plus c. So ultimately your f of z is equal to 1 by 2 log z square plus c. This is your f of z. This is your f of z when y is in terms y is if n u is given, then find out v and write down the function f of z. So f of z is equal to 1 by 2 log z square plus c. Okay. Now next is show that the function u is equal to, now just read it, show that the function, I will be back within 1 minute, exactly similarly we have to find out. Okay. So we'll see how to find out the harmonic and its harmonic conjugate. Exactly similar way, just for the practice you can find out here u. So u is given, you can find out v. So u is equal to e raised to x into x square minus y square cos y minus 2xy sin y is harmonic and its harmonic conjugate is. So dabba u by dabba x. Dabba u by dabba x is equal to here e raised to x into x square minus y square cos y minus 2xy into sin y. First into derivative of first into second plus second into derivative of first. Your first into derivative of second respect to x. So ये हो जाएगा 2x into cos y minus 2y sin y. Right? Now dabba u by dabba y. Harmonic conjugate. First of all, show that it is a harmonic function. So harmonic function, it means we have to show that it is dabba square u by dabba x square plus dabba square u by dabba y square is equal to 0. Right? We have to show that dabba square u by dabba square plus dabba square y upon dabba square u upon dabba y square, okay, is equal to 0. So calculate dabba u by dabba y. So here e raised to x as it is. So keeping this, measuring this 2y into bracket, then get x square into, okay, we'll get dabba square u. First we will calculate dabba square u by dabba x square. So immediately we will get here. So dabba square u by dabba x square, you will get first derivative of this with respect to x. Get square minus y square into cos y is 2xy into plus s to x bracket this again. Derivative of this is again, you will get 2x plus 2x into cos y. Right? 2x into cos y minus 2y sin y. Right? So this will give you e raised to x into bracket 2x plus 2 first, keep derivative of first into second plus second into derivative of first with respect to x minus 2y sin y plus this is like this. First into derivative of second 2 cos y minus 0 plus second into derivative of first e raised to x into bracket 2x y 2y sin y. Okay, so this is your dabba square u by dabba x square. So you can write in short here dabba square u by dabba x square is equal to, you will get e raised to x into bracket 2x plus 2 into cos y minus 2y sin y plus e raised to x into bracket x square minus y square plus 2x into cos y minus 2y sin y into x plus 1, right? And dabba u by dabba y. Dabba u by dabba y is equal to e raised to x into bracket minus of x square minus y square into sin y minus of x square minus y square into sin y plus cos y into minus 2y minus 2x into bracket y cos y plus sin y. Okay. So dabba square u by dabba y square is equal to e raised to x into bracket, you will get minus of x square minus y square into cos y plus 2y sin y plus 2y sin y minus 2 cos y minus 2x into cos y minus y sin y plus cos y plus cos y. Okay. All this is your, adding all this as equation number 3 and this is your equation number 2. So adding 2 and 3, we'll check whether we are getting 0 or not. Okay. So adding 2 and 3, we are getting, here is dabba square u by dabba x square plus dabba square u by dabba y square is equal to e raised to x into bracket 2x cos y plus 2 cos y minus 2y sin y plus x square cos y minus y square cos y plus 2x cos x plus 2x cos y plus 2x cos y plus 2x cos y minus 2y cos minus 2y sin yx minus 2y sin yx minus 2y sin y minus x square cos y plus y square cos y plus 4y sin y minus 2 cos y minus 2 cos y minus 2x cos y plus 2xy sin y minus 2x cos y, right, which is equal to 0, right? Here u is harmonic function. अभी यहाँ पे सारा cancel out हो रहा है देखो, so ultimately you will get it is 0. So this, which implies u is harmonic function. As it is harmonic function, you can find out v. So for harmonic conjugate v, we'll find out harmonic conjugate v as, here v is a function of xy, तो आपको मिलेगा यहाँ पे dv is equal to dabba v by dabba x into dx plus delta v by delta y into dy. Okay, so by CR equations, here we will get delta v by delta x is equal to minus delta u by delta y and delta v by delta y is equal to delta u by delta x, which is equal to minus delta u by delta y into dx plus delta u by delta x into dy. Okay, so we'll get here dv is equal to, writing here only, I hope you are getting it how to find out the so here we can write our CR equations. So we will get here delta v by dv is equal to, we can write directly dv is equal to minus delta u by delta y and delta v by delta y is equal to minus delta u by delta y plus into dx plus delta u by delta x into dy, right? So just put all the values. So delta v is equal to minus e raised to x square minus y square plus 2x into cos y minus 2y sin y into bracket x plus 1 into dx plus e raised to x into minus of x square minus y square into sin y plus cos y into minus 2y minus 2x into bracket y cos y plus sin y into dy. Okay, so if it is the of the form, here you will get du is equal to m dx plus n dy. So ultimately integrating this, so you will get after integration, so v is equal to now, here after integrating you will get v is equal to minus of integration of e raised to x into x square minus y square plus x square minus y square plus 2x into cos y minus 2y sin y into x plus 1 dx plus integral of 0 dy plus c. Okay, so you will get v is equal to, now integration of this you will get minus cos y into x square e raised to x minus 2x e raised to x plus 2 e raised to x minus 2x e raised to x minus e raised to x into y square plus 2x e raised to x minus 2 e raised to x minus y sin y into x square minus 2xy sin y plus 0 plus c. Okay, so your v becomes, v is equal to e raised to x into x square minus y square into cos y minus y sin y into x square minus 2x plus c. Okay, I hope you are getting it here. Put x is equal to x, put x is equal to z and y is equal to 0. So your f of z becomes here f of z is equal to, so v is equal to here e raised to z into z square y0 cos 0 is 1, so this will becomes y0, so or obviously this is 0, so your v is equal to e raised to z into z square plus c. Okay, now see little bit यहाँ पे इंटीग्रेशन डेरिवेटिव है तो आपको यहाँ पे समझ के करना है. So इंटीग्रेशन क्या है, डेरिवेटिव क्या है, u into v रूल अप्लाई करना है आपको यहाँ पे. The last example, find the analytic function whose real part is. Now real part is given. Instead of telling it is u, here real part is given. So you can you find out this real part is given, then find out the v. So here u is equal to sine x, sine 2x cos h2y minus cos 2x. Okay, sine cos h2y minus cos 2x. So u is equal to this. So calculate first del by u by del by x, then del by u by del by y, and accordingly we will calculate the v. Okay. Analytic function, it means we have to find out f of z only, so that is u plus iv. So first of all calculate. So here your f of z is equal to u plus iv. So f dash of z is equal to del by u by del by x plus I into del by v by del by x. Right? So calculate del by u by del by x first. So del by u by del by x, you will get here v upon u upon v rule. So v du cos h2y minus cos 2x into derivative of sin 2x, that is 2 cos 2x minus sin 2x into bracket minus sin 2x into bracket derivative of cos h2y minus cos 2x. So you will get here cos 2x. So calculate here cos 2x sin h2x. So I will do in the next page, so that it is very simple to calculate here. U is equal to sin 2x minus on cos h2y minus cos 2x, right? Cos h2y minus cos 2x. So here you will get f dash of z is equal to f of z. So that is del by u by del by x plus I into del by v by del by x. So replacing by CR equation. So del by u by del by x is equal to, you can write as it is del by u by del by x, but del by v by del by y, you can write minus del by I del by u by del by y. Okay. So you will get f dash of z is equal to here del by u by del by x. So del by u by del by x, you will get, here is cos h2y minus cos 2x into 2 cos 2x minus sin 2x into sin 2x into, we will get here derivative of this cos h2y 2 sin h2y minus plus 2 sin 2x, right? Minus 2 sin 2x. So here you will get upon cos h2y minus cos 2x bracket square, right? v du minus u dv upon v square. So minus I into bracket, directly you can write cos h2y minus cos 2x. That is only cos h2y. Derivative of this is 0 because it is function of y. Okay. That is cos h2y minus cos 2x upon u by double y. So I into cos h2y minus cos 2x into 0 आएगा है ना, minus sin 2x into bracket sin h2y 2 into sin h2y sin h2y sin h2y derivative of this upon cos h2y minus cos 2x ब्रैकेट स्क्वायर. देखो यहाँ पे डेरिवेटिव क्या है, v du माइनस u dv अपॉन v स्क्वायर माइनस I into u dv minus v du upon v square. Okay, so you will get f dash of z is equal to here, f dash of z is equal to, you will get 2 cos 2x into cos h2y minus 2 upon, now you can see here, cos h2y minus cos 2x bracket square. Okay, now you can see 2 cos 2x, 2 cos 2x into cos h2y minus cos 2x, and minus this is 2 sin square 2x, right? Minus 2 sin square 2x. So you will get here 2 upon cos h2y plus I into bracket 2 sin 2x into sin h2y upon cos h2y minus cos 2x bracket square, right? So ultimately this is f dash of z is equal to, you will get little bit, that is difficult, so you will get by Milan-Thomson method, replace by Milan-Thomson method, replace x by z and y by 0. Okay, so that you will get here x by z, it means f dash of z is equal to 2 cos 2z y 0 minus 2 upon cos h2y, so 0 is 1 minus cos 2z bracket square plus I into 2 sin 2z 0, so this will become 0, so I into 0, so this is your f dash of z. So on integrating we will get integration of f dash of z dz, we will get integration of this is ultimately, first of all just simplify this, so you will get f dash of z is equal to, here 2 into bracket cos 2z minus 1, right? 2 into bracket cos 2z minus 1, so here you will get minus 2 into bracket 1 minus cos 2z upon 1 minus cos 2z bracket square. This one becomes cancel out, so minus 2 upon 1 minus cos 2z plus c upon 1 plus c. So f dash of z is equal to this, right? F dash of z is equal to this, so you will get f of z is equal to integrating 1 upon 1 minus cos 2z, that is, you will get 2 sin square z. So here f dash of z is equal to minus 2 upon minus 2 upon 2 sin square z, right? So these two to cancel out, so f dash of z is equal to 1 upon sin square z, which means cosec square z, and integration of minus cosec square z, it means f of z is equal to cot z plus c. So this is your function f of z in terms of z. So ultimately again find the conditions under which u is equal to ax cube plus byx square y plus cy cube cxy square plus dy cube. Find the condition under which u is harmonic function. Is harmonic function. Okay, so we know that u is harmonic when delta square u by delta x square plus delta square u by delta y square is equal to 0. So u is given, so replacing delta u by delta x, we'll get delta u by delta x 3ax square plus 2bxy plus 2c no plus cy square. This is your delta u by delta x. Now delta square u by delta x square, we will get 6ax plus 2by. Okay, all this is equation number 1. So exactly similar you can calculate. U is equal to given ax cube plus by square bx square y plus cxy square plus dy cube. So calculate delta u by delta y. So delta u by delta y is, that is 2bx square plus 2cxy plus 3dy square. Delta square u upon delta y square is equal to 2cx plus 6dy. Okay, 2cx plus 6dy. Call this as equation number 2. Now adding equation 1 and 2. So we will get, adding equation 1 and 2, 6ax plus 2by, 6ax plus 2by plus 2cx plus 6dy is equal to 0. Okay, as we know that it is harmonic, so delta square u upon, I'm writing again it here, delta square u upon delta x square, delta square u upon delta x square plus delta square u upon delta y square is equal to 0. So you will get here 6ax plus 2by, 6ax plus 2by plus 2cx plus 6dy is equal to 0. Okay, so comparing this equation, you will get 6ax plus, so you will get 2x into bracket 3a plus c plus 2y into bracket b plus 3d is equal to 0, which implies c is equal to minus 3a and b is equal to minus 3d. The value. Okay, that's it. Now I hope you are calculating the again same way in terms of z, f of z in terms of z. Just derivative and integration you need to find out the any complex function, whether it is analytic or not, and harmonic conjugate or not. Okay, in next lecture we will see the complex integration, the most important point, that is our how to find out the integral by using Cauchy's integral formula, Cauchy's integral theorem and Cauchy's residue theorem. Okay, I hope you are clear this. So thank you for watching. So tomorrow I will be here with the same time and the new topic, that is complex integration. In that we will see Cauchy's integral theorem, Cauchy's integral formula and Cauchy's residue theorem. Okay, thank you so much. Thank you for watching. If you are liking my videos, please do share, like and subscribe. Thank you so much.